Hey, this is Math 105, Section 5.4. We're going to look at the graphs of the other trig functions. We're going to place most of our focus on tangent, but we will look at cotangent and secant and cosecant a little bit. Okay, so we're looking at the graphs of those four functions. Okay. Now remember that sine and cosine have period 2 pi. Now remember cosecant's a reciprocal of sine and secant is the reciprocal of cosine. Okay, so that means they also have period 2 pi. Okay. And then tangent and cotangent have period pi, okay? So remember the period, that means we can add that to the input and we get the same output. So the periodic properties for tangent and cotangent have period pi, which means tangent of x plus pi equals tangent of x. Doesn't change when you add pi to your input. And cotangent of x plus pi equals cotangent of x. Doesn't change when you add pi to your input. Okay. And then just like sine and cosine, cosecant and secant have period 2 pi. So cosecant of x plus 2 pi is cosecant of x, and secant of x plus 2 pi is secant of x. Okay? Okay, because the graph of tangent has period pi, we only sketch the graph on any interval of length pi, and then repeat, okay, to the left and the right. Okay. So we look at the interval minus pi over 2 plus pi over 2. Because tangent of pi over 2 and tangent of minus pi over 2 are undefined because that's where cosine is 0. Okay, so we can't divide by 0, right? So, so what happens at points near pi over 2 and minus pi over 2, as x gets near pi over 2 through values less than pi over 2, the value of tangent of x becomes very large. It goes to infinity. Okay, and that's a vertical asymptote there for the graph. And the reason for that is because as x gets close to pi over 2, cosine of x approaches 0 and sine of x approaches 1. So that means tangent of x equals sine of x over cosine of x is large. So as an example, we've got something like this. Tangent of x, now this is as we approach pi over 2 from the right-hand side, is approximately 0.9999, close to 1 over something that's really close to 0. And that gives us a really large positive number. So it goes to infinity as we get closer and closer to 1 on the top and closer to 0 on the bottom. Okay, so that's as x gets close to pi over 2 from the left-hand side. Okay. Okay, so we can see as we get closer to, see we're going x, pi over 6, pi over 4, pi over 3, and then we're getting closer to pi over 2. So here we're not using pi over 2, we're using like radians, but 1.4, 1.5. Pi over 2 is approximately 1.57, a little more than this, right? But you see what happens with tangent. It blows up, it gets really high as we get close to that pi. See, this is pi over 2 without using, as a number, decimal number. So you see our tangent goes to 10,000. It keeps going higher and higher. Okay. And then it does a similar thing at x equals minus pi over 2, but it goes down to minus infinity. So the graph, sorry, I'll use blue there. Okay, the graph of y equals tangent of x approaches the vertical lines x equals pi over 2 and x equals minus pi over 2. We call those are vertical asymptotes by definition. Okay. Okay, so this is what our graph looks like. This is minus pi over 2, this is plus pi over 2. It keeps going down here and approaches that vertical asymptote, as you approach minus pi over 2 from the right-hand side. And then as you approach pi over 2 from the left-hand side, as we showed, it goes to plus infinity. So it goes like that, and that just repeats. So when we go, remember this is the length of pi, so when we go to 3 pi over 2, we get the same thing repeating. Okay. So this is our basic cycle of tangent of x. And notice it's undefined at minus pi over 2 and plus pi over 2, because that's where cosine is 0. Okay, and now we look at a couple of cycles. So here's our cycle that was in the middle, right? And we're going from minus pi over 2 to plus pi over 2. And then the next cycle would go from pi over 2 to 3 pi over 2. Notice that's a cycle of pi, because pi over 2 to 3 pi over 2 is the length of pi. And then the one to the left would go from minus 3 pi over 2 to minus pi over 2. So notice where, first of all, where it's undefined wherever cosine is 0. Okay, so cosine is 0 at minus 3 pi over 2, at minus pi over 2, pi over 2, 3 pi over 2. Anywhere we're here on our circle. Okay, we're here or here, right? That's where tangent is undefined. Okay, Where is tangent equal to 0? Wherever sine is 0. So that would be, I'll put a little x there. I probably should do x on the other one, but okay. So this is where tangent is 0. Okay. Minus pi would be here, right? 0 would be here. Pi would be this, right? So this is where tangent is 0. And these little marks here are where tangent's undefined, you know. So minus pi over 2 would take us there. Plus pi over 2 would take us there. 3 pi over 2 would take us here. Minus 3 pi over 2 would take us there, right? So see, anytime we end up here or here, we're going to have 0 for cosine, which means tangent's undefined. So we're going to have those vertical asymptotes. Where we end up here or here, tangent is going to be 0 because sine is 0. Okay. So that kind of shows you how that cycle works, and we can see why it's undefined, you know, for length of pi, because it, you know, think what tangent does. As it goes from here to here, it's going up to infinity. As it goes from here to here, it's going down to minus infinity, and then it just repeats the process. Okay. And without getting into too much detail, this is what cotangent looks like. Now this has vertical asymptotes at 0 and pi, and it still has that cycle of pi. And we can say, well, yeah, remember cotangent is cosine over sine, right? Over sine. Okay. So that means it's going to be undefined wherever sine is 0. When sine is 0 at 0 is at 0, and sine is 0 at pi, right? And then where's cosine 0? At pi over 2, so that's where the cotangent 0. So it looks similar, it's just going down instead of up. And then that's our basic cycle, and it just repeats. Okay, so if we look at that repeating cycle of cotangent, we can see, you know, the undefined. Again, I'll draw the circle to show where it's undefined. Okay, and I'll do the same thing. So now here, this is where cotangent is 0. I'll put an x like I did before. So this is where cotangent is 0. Okay, and that would be pi over 2. Well, let's do the other part first, 2. So that's where cotangent is 0, and this is where cotangent's undefined. Okay, so it's undefined here because your sine is 0, right? Okay, so it's undefined at 0. Okay, it's undefined at pi, right there. It's undefined at minus pi, which is there, and etc. So we can, anytime we go from here to here, the cotangent's undefined. Now pi over 2, it's 0, right? Because remember it's cosine over sine, and cosine is 0 there. So at pi over 2, it's 0. Okay. At minus pi over 2, it's 0. Okay. And then at 3 pi over 2, it's 0. And at minus 3 pi over 2, it's 0. Okay. So just to show you, I'm looking, here's where cotangent is 0. Here's where cotangent is undefined. Okay. And that would be, you know, undefined would be these two, 0 would be these two. Okay, so wherever you end up in one of those spots, it's either undefined or 0. Okay, and for cosecant and secant, remember cosecant is 1 over sine of x. It's a reciprocal identity, right? So if we're looking at y equals cosine of x for the graph, we take the reciprocals of the y coordinates of the points of the graph of y equals sine of x. Okay. So in this case, we have our sine curve, the blue one, and if we take the reciprocals, now let's start with 1. 1 over 1 is 1, so they're going to be the same there. And 1 over minus 1 is minus 1, so they'll be the same here. But then we have fractional values for our y, otherwise for the blue, right? And we have here, think of it like if this is a half, you know, here, then it's 2 over here. If this is a third, then it's 3 over here. Now, if we get to really small fractions, like 1 over a million, this is going to be a million, right? So you can see that this thing is actually going to blow up. It's going to go up to, we're going to have vertical asymptotes. See, this cosecant is undefined at 0 and pi, and 2 pi, and 3 pi, because that's where sine is 0, and we can't divide by 0, right? So think of the reciprocal of this thing. You know, we have a little fraction, we get a big number, right? So the red is our cosecant, sorry. And you see how it kind of it bounces off, kind of bounces off these and then goes way up. So we have vertical asymptotes for cosecant. Okay, at 0 pi, 2 pi, 3 pi, minus pi, etc. Okay. Okay, now if we look at y equals secant of x, we take the reciprocals of the y coordinates of y equals cosine of x. Remember, y equals secant of x is 1 over cosine of x. Okay, so the blue is our cosine. It starts at 1, and then it goes down to 0 at pi over 2, goes down to minus 1 at pi, goes back to 0 at 3 pi over 2, and then it goes up to 1 at 2 pi, right? So the red will be our secant, which is the reciprocal. So when y is 1, 1 over 1 is 1, so they're the same. When y is negative 1 for the blue, 1 over minus 1 is also minus 1. So those are the same, and then it's same here for 1 and 1. Okay, but as we get to fractional values of cosine, like a half, our secant, the red, will be 2. If we get to a third here, we'll have 3. If we get to 1 over a million here, then we have a million here. So you can see that the secant curve approaches this vertical asymptote because it's undefined at pi over 2, where cosine is 0, and 3 pi over 2, where cosine is 0, etc. So every pi radians, beyond that, 5 pi over 2, 7 pi over 2, etc., minus pi over 2, it will be undefined. Okay, and it's actually the same as our cosecant graph, except it's shifted. So it kind of has the same relationship to the sine curve as this does to the cosine curve. Okay. Cosecant has the same relationship to the sine curve as secant does to the cosine curve. And it kind of, plays off it, bounces off it, and then it's going to have vertical asymptotes because it's undefined there. Okay, so they look the same, they're just shifted. Okay, and it's easier if we see them in relation to the cosine or the sine curve. Okay, now getting back to our cosecant graph. Okay, we just extend it to more than more than one period, so it's periodic with period 2 pi, just like sine, because it's the reciprocal of sine. And the graph has vertical asymptotes where sine is 0, right? Okay, and that would be x equals n pi for n as any integer. So pi, 1 pi, 0 pi, 2 pi, minus pi, etc. We're going to have those vertical asymptotes. Okay, and we can see it's just it's bouncing off the sine curve, which is the sine curve is going like this, right? Okay, and like this. Okay, let me draw the sine curve in there, so just to kind of see, not very well, but I'm going to draw it, kind of going like that, right? And then it's going down here and then up. Okay, so just reflect, that would be our sine of x, and that you can see that the cosecant is the reciprocal. Now these should meet here, so make sure that those meet at the the vertices there. Okay. Not the vertices, but the kind of the top of the hill, bottom of the hill. Okay, so that's cosecant just extending to more than one cycle. This is secant extending to more than one cycle, and I'll kind of draw cosine just so we can see how it's relating. Again, I'm trying to hit the points, but I'm not doing a very good job. Okay, so that's it. Sorry, it's going down there, and that goes like that, right? Okay, so that black is cosine, and we're looking at secant in relation to that. Okay, so the graph of secant, y equals secant of x, domain is a set of all real numbers other than x equals pi over 2 plus n pi, okay, for n an integer, okay, which is where it has vertical asymptotes, okay, because that's where cosine is 0, and we can't divide by 0. So think about wherever cosine is 0, that we're going to exclude that from our domain of secant, because that's a reciprocal of cosine, okay. Now, because tangent, cotangent, and cosecant are odd functions, okay, the graphs of those are symmetric about the origin, okay? And because secant is an even function, remember that corresponds to cosine, the graph of y equals secant of x is symmetric about the y-axis, okay? So remember, because, this one points to cosine, right? This is reciprocal of cosine, right? And we know cosine of x is even, right? So that means secant is even. So that's symmetric about the y-axis. But tangent, cotangent, cosecant, all the other ones are symmetric about the origin because those are odd functions. Okay, now we're going to look at transformations of tangent and cotangent. We're not going to worry about transforming secant and cosecant. So we'll focus on these two and then move on. Okay, remember they have period pi. Okay. And if we have something like y equals a tangent of kx or y equals a cotangent of kx, what we're doing is we're completing one period as kx varies from 0 to pi as opposed to just x. So remember that means k of x goes from 0 to pi because remember our cycle is pi. Okay. K is positive. Okay. And that means when we solve for x, we get x is between 0 and pi over k. Okay, so the period is pi over k. That's the key there, is that we take pi and divide it by k. Instead of, remember for sine and cosine, we take 2 pi divided by k to get our period. For tangent and cotangent, we're going to take pi divided by k because the period is just pi for tangent and cotangent. Okay, just to summarize, tangent and cotangent curves. So y equals a tangent of kx and y equals a cotangent of kx, where k is positive, have period pi over k. Okay. Okay, so let's look at an example. Let's look at the y equals tangent of 2x. So our k is 2 here. So our period is pi over k. So our period is pi over 2. And instead of going from minus pi over 2 to plus pi over 2 for our tangent curve, now we're going to go from minus pi over 4 to plus pi over 4. So we're shortening our cycle by a half. Okay. So these are our vertical asymptotes now. X equals minus pi over 4, x equals plus pi over 4. Has the same shape of the tangent, but it's shrunk horizontally by a factor of a half, and that's because we shortened our cycle. Okay. So we can see our tangent graph, instead of going from minus pi over 2 to plus pi over 2, it's going from minus pi over 4 to plus pi over 4, and then it repeats the same fashion. So now that our cycle is only pi over 2, the next one would be minus 3 pi over 4 to minus pi over 4, when the next tangent cycle would be. And then going this way, we go from pi over 4 to 3 pi over 4. So you notice that this distance here is no longer pi, right? Our cycle is now pi over 2. Okay. Pi over 2, pi over 2. Okay. For each of these. Okay. This one also. Okay. So we're basically, it's going to be the same height. It's just that we made our cycle shorter. So the horizontal is compacted. Okay. Okay, let's look at part B, which is y equals tangent of 2 times x minus pi over 4. Now this is a phase shift, okay, and we have to make sure that we factor out the k before we see what our phase shift is. So we have our k is 2, which means our period is pi over 2, right? So our period is no longer pi, it's pi over 2, just like we did for the previous graph, right? So it's going to have a cycle of pi over 2, but we're shifting it pi over 4 to the right, okay, because we have x minus pi over 4. And that's when your k is factored out, so that's important. So we just took the graph that we had from the previous one and just shifted pi over 4 to the right. So remember, it was going through here, but it was going like this before, going through 0, and then through pi over 2 and pi. Now it's going through pi over 4 and through pi over 4. We shift everything to the right. So also the vertical asymptotes get shifted to the right by pi over 4 as well. Okay. So when we do that shift, everything gets shifted, the cycles and the vertical asymptotes. Okay. So that's all we did. We took that graph from the previous one and shifted it to the right by pi over 4. Okay, we're going to just focus on doing shifts and transformations of sine, cosine, and tangent only. So for cotangent and secant and cosecant, I just want you to be able to graph those as they are, the standard form, and know what they look like. Maybe in relation to sine and cosine and in relation to tangent, but we won't worry about doing shifts or transformations of cotangent, cosecant, or secant.